Good afternoon, my dear JEE Advanced 2024 warriors. Welcome to the next session of your JEE Advanced class. And today we are going to do questions on electromagnetism, right from electrostatics, Gauss law, capacitors, current, electricity, to electromagnetic induction and magnetic effects of current. So all these topics are very important. Again, IIT always loves mechanics and electromagnetism, that have been their all-time favorites, and this is like your classical, you would say, physics questions, right? So these days they have found a newfound love, which is the modern physics as well. So we'll be taking up a class on that soon, maybe by Monday or maximum Tuesday, right? So for now, quickly join in the session, get your friends along, and I hope you enjoyed the yesterday's class as well on mechanics. So let's get started with electromagnetism with your captain Shreyas, your physics master teacher. Hello Sohaib, Rajeshwari, welcome. Kumar, hello. Alandari, hello. Ahmad, hello. Kenizad, background is good, thank you. IIT Madras degree, it will be worth it, definitely. Okay, so let's begin with the lecture, and I hope you guys have marked your attendance by smashing the like button. Do that. Don't be so confused, don't be so such a miser. Give your love, give your support to the channel, because we are doing this for you. You cannot think, oh, it's okay, something, I am going to become IITian, why should I like all this? Oh, somebody will do it, no problem. Don't have that attitude. That will never help you in life, remember that. So smash the like button and subscribe to the channel. Thank you so much for doing so. Starting with the first question on your screen. It's a single correct question. We will have multiple type of questions. There is a passage also, there is matrix type also, right? So all mixed variety of questions we are going to take today. So there are two particles of the same mass having the same magnitude of the charge. One is at rest on a smooth plane, and the other is projected directly towards the particle from very far away distance, the distance of the closest approach. I don't need the options. Probably, I think I have a blank screen. I will use that. Read the question again so that you understand it. See, two identical particles, same mass, same charge. One is at rest, smooth surface, and the other one is thrown towards it from a very far away distance. So the diagram should look something like this. This is one particle, right? And the other particle is really far away. So I will put this as infinite separation, or very far away separation. Okay, this is how it is. Now what happens once the distance starts reducing? Then there will be a repulsive force between them. So because of which this particle will begin to move towards left side, this particle will slow down a bit, and there comes a moment, because of their repulsion, they will definitely experience repulsion. There will be repulsion between them. Remember, this particle was the only one which was thrown with some velocity v, whereas the other one was basically at rest. So due to this repulsion, this guy will begin to move, this guy will begin to slow down, and there comes a moment when this is slowing down, the other one is increasing the speed, both their velocities will be equal. You know what happens when their velocities are equal? I'll give you an example. Just understand it through an example. Imagine this guy has 0 speed, this guy has 10 meters per second. This guy slowly goes with 2 meters per second. This guy reduces the speed by 1 meter to come to 9. This increases to, let's say, 3. This becomes, let's say, 7. This goes down further. Let's say this becomes 4. Let's say, this becomes 6.5 or something. This increases further. Let's say this becomes 6, and this also becomes 6. When both the speeds are equal, then there is no further change in the distance between them, because the relative speed will become 0. The relative speed will become 0. So think as if their speeds reduced. Let's say it became 6 and 6. If this increases further to 7 and this decreases further, let's say, to 5, then their separation will increase. Here their separation was decreasing. Here this separation is going to be minimum. Did you understand this concept? Why the velocity should be equal or the relative velocity should be 0 so that their separation is minimum. This also works for maximum separation. Give me a thumbs up quickly. Give me a thumbs up quickly. Everyone. Okay? Everyone? Everyone clear about this? Everyone clear about this? Okay, very good, very good. Awesomeness. Now, if you understood this, let's draw that situation where both of them are moving together. Both of them are moving together. So let's say this has a new speed u, this has a new speed u, and this other mass has come very close to it, and it also has a new speed u, and the separation between them is right now r, and this is obviously minimum. This is obviously minimum. This is the least separation when both their speeds are equal. So I would also say relative velocity is 0. That is why they have same speed. That is why they have the same speed. Very good. Awesomeness. Now, next thing. What is this speed going to be? Do I need this speed? I think so. I need to find out this speed. How do I find out this speed? Think logically. You might be like, sir, should I use energy conservation? I don't think so, because you do not know this r. In fact, you have to find that distance r. Hello, Namrata. Yeah. So how do I find out? Use some other principle which might work. What might work? Think about it. There is repulsion force. That repulsion force is an internal force. It's not an external force. So the internal forces cannot affect the total momentum of the system. That's right. The total momentum of the system should remain conserved. So let us use basically the total momentum conservation. Total momentum, the total momentum should be conserved. The total momentum should be conserved since there is no net external force. So what is the initial momentum versus the final momentum? Initial momentum, if you notice, this guy has 0 momentum. This guy has 0 momentum. What about this guy? That guy has a momentum of m into v. That guy has a momentum of m into v. What about the case later on? What about the case later on? This guy has a momentum m into u, whereas the other guy has momentum of m into u again. So what will your u be? Mu plus mu is 2mu. Mm cancels. It will be nothing but v divided by 2. So the new velocity is half the original velocity of the first particle. Is that understood? Everyone got it till this point? Very good. If you have understood it till this point, let's go to the second part of the problem, because this was not this was not asked, but it was needed to solve the problem. The question is to find the distance r of closest approach. Now I think we should go to energy conservation. Now let's go to energy conservation. Energy conservation, because energy is conserved. Energy is conserved because there is no friction. Remember, it is given to be smooth, frictionless surface, no resistive force. So the total mechanical energy is conserved. So what are the energies? Let's try to write it down. This system does not have electrical energy because the infinite separation will not give it only any electrical energy. Far away distance, so no electrical energy as such. No electrical energy. No electrical energy. What about kinetic energy? This guy has no energy kinetic wise. That guy has kinetic energy, which is half mv square. Half mv square. Later on, when they are moving together for minimum separation, they have electrical energy. In fact, that electrical energy is k q q divided by r. K q q divided by r. That is the electrical potential energy. Plus, both of them have kinetic energy. It is half mu square, but 2 times. Why 2 times? Because there are 2 masses. Why 2 times? Because there are 2 masses. Is this very, very clear till this point? Awesomeness. Very good. Now, let's go ahead and solve this. Let's see what does it turn out to be. Half mv square is equal to k q square divided by r plus half and 2 gets cancelled. So forget that 2. M into u is v by 2. So it will be v square divided by 4. Shift these people over here. Half minus 1/4 is 1/4. So 1/4 mv square is k q square divided by r. Shift r on the top, shift 4 on the top, mv square, bring it down. So r will be 4 times k q square divided by mv square. But wait a minute, k is 1 by 4 pi epsilon naught. So I can also write k as 1 by 4 pi epsilon naught. This will become 4q square divided by mv square. K is written down as 1 by 4 pi epsilon naught. 4q square is there, mv square is there. 4 will cancel. You will get q square by pi epsilon naught mv square. Okay, 4 is there. It will get cancelled. This is exactly the answer which we needed. So if you notice, this problem involved 3 major chapters. Obviously, electrostatics was involved over here. You can see even total momentum conservation is also involved. Also, total energy conservation is also involved. In fact, there is one more 4th chapter which is involved, and that is the concept of relative motion. So 4 major chapters were involved in solving this question. In fact, you can see. Okay, is that clear? Everyone with me on this? No, it will not be so useful for EMSAT if you prepare for JEE Advanced, because JEE Advanced is much higher level than EMSAT or anything else. Cool? Did you love this question, my dear students? And I hope you guys have smashed the like button and also subscribe to the Vedantu JEE English. Cool. Let's move on to the next one coming up on your screen. There is a conductor of length L. It is going down without any friction on 2 vertical conductors. There is a rod. That rod is sliding down on 2 vertical conductors. So gravity is downwards. Length of the rod is L, mass is m, and they are connected through a capacitor. You can see this conductor and this conductor, they are connected via a capacitor. Wow, what a beautiful question. Gravity is there, even magnetic field is there, rod is under motion, capacitor is also there. Again, you can see it's a mixed concept question. A uniform magnetic field is perpendicular to the plane of the paper. The acceleration of the conductor is. Very nice question. Let's see. I hope you have understood what the question is, how to solve. Maybe you have not yet figured it out. We will figure it out together. Are you able to visualize? Okay. So let's try to solve it. First of all, I don't know whether the velocity is constant. Second of all, if the velocity is not constant, the charge on the capacitor may also change with time. Third of all, if the charge changes, the current might also change with time. You might be wondering, sir, what has this got to do with anything? See, when a rod moves in a magnetic field, what does it create? It creates, or it behaves like a battery, so it creates a voltage difference. Yes, it's motional EMF. Remember, you move a rod in a magnetic field, BLV is the EMF or the voltage which is created across the ends of the conductor. So if it behaves like a battery, this battery is connected to the capacitor. So what will the capacitor do? It will get charged. Once it gets charged, there is some current flowing in it while it is charging. The problem is, if the voltage is not constant because the velocity is changing, then even the charge won't remain constant, even the current won't remain constant. And if the current does not remain constant, there is one more problem which is going to happen. And what is that problem, guys? You might see that there is an ILB force. Remember, Lorentz force on charges and current carrying wires. If a wire is carrying current, there is a magnetic force of ILB acting on it. Even that magnetic force might change. It's like a vicious circle. Okay, I hope this is understood. So we have to be very careful when we solve it. Everything is a variable here that should be there in our head. Nothing is constant as of now. Some things might end up being constant after solving it mathematically. Okay, so this problem is equivalent to, this problem is equivalent to saying you have a capacitor, and you have a battery, something like this. This is having EMF E, which is equal to BLV. So it produces some current over here. There is some charge stored on it. And because there is current flowing, because of that current, there is a ILB force which will resist the motion. Simultaneously, there is mg, because gravity also has to be there downwards, and the net result of all of this is it is accelerating. And that is exactly what we need to find. So let's go step by step. How much might be the charge on the conductor? Let's try to figure this out. How much is this particular charge on the conductor? This charge will be C into E, but this E is itself B into L into V. That is your motional EMF concept. Once I know the charge, now I can also find the current. Now the current in the conductor, which is dq by dt, will be C is a constant, B is a constant, L is a constant, velocity may not be a constant, so dV by dt. What is the dV by dt? Because derivative, right? So you have to take somebody's derivative, it will be dV by dt. What is dV by dt, my dear warriors? What is the dV by dt? It is rate of change of velocity, so it is acceleration. So current is capacitance into field into length into acceleration. Keep it on the sides. Now go to the free body diagram. See, Newton's laws is also involved. The net force will be mass into acceleration. Let's use Newton's laws of motion. According to Newton's laws of motion, your gravitational weight is downwards. The magnetic force of ILB is upwards. This is the net force, is going to give you mass into acceleration. Therefore, mg minus current is nothing but your C into B into L into A, and this L and B is as it is equal to M into A. Therefore, mg is equal to, you can see MA is over here, shift these people on this side, C is there, B is there 2 times, L is there 2 times, A is there once. So C B square L square into A. You can see A and A is common, the rest of the people I can put it down. So it will become mg whole thing divided by M plus C B square L square is equal to acceleration. This is exactly what we wanted. I think, yeah, okay. The answer is not mentioned, but this is the answer. Perfect. And you know what is the best part about this problem? Can you guess? Is the acceleration increasing or decreasing, or is it constant? Come on, put it up in the chat box. Is the acceleration increasing, decreasing, or is it constant? Quickly put it up in the chat box. What is it doing? What is it doing? Yes, come on, my dear warriors. It is constant. Exactly. That is the best part. So this acceleration surprisingly turns out to be constant. And we did not know this before solving the problem. Let me tell you that. You did not know it. The mathematics has proved it. M, G, C, B, L, everything is a constant. So that means, can we use kinematic equations? Yes. We are allowed to use kinematic equations in this particular problem only because acceleration turned out to be constant. Otherwise, we cannot use that. Yes, so we can use equations of motion. Who is that? Pratham. Correct. Hello, Darshini. Yes. Very nice. Let's move on to the next beautiful question coming up on your screen. There is a proton. It is accelerated through a voltage difference, moves through a field shown in the figure. The angle by which the proton deviates by is a question. I think to find out the angle by which it deviates, you need to understand why it is deviating. First of all, it is because of the magnetic field. So it will try to go in a circular path, of some radius. So if I know the radius using some geometry, I might be able to find out the angle. Think about it, why geometry might be involved. Probably I will create a duplicate of this. Oh, okay, I have a blank slide also, no issues. Perfect. See, it starts going in a circular path once it enters a transverse magnetic field. That is a standard thing which you should know. Any charged particle thrown in a transverse means perpendicular field, goes in a circular path. So this is the arc, this is the center of the circle, this is the radius, this is also the radius. So in order to find this theta, I can find this theta also. This theta and this theta are the same, by the way. If you are wondering how they are the same, think like this. My pointing finger is horizontal, my thumb is downwards. If I rotate my hand by 20 degrees, both the fingers will rotate by 20 degrees. Both the fingers will rotate by 20. If I rotate by 50 degrees, both will rotate by 50 degrees. So think like this. The pointing finger was the velocity. Downward direction is the radius. Downward direction is the radius. So if I go around like this, isn't the pointing finger turning by theta? So my thumb also should turn by theta. This trick I teach in my batches most of the time, so I am giving it off to you. This is my trick of using the hand, placing the two fingers perpendicular, and I just rotate it. Especially for arc problems and even inclined plane problems, I usually use these two fingers and then I rotate it like this. If one finger rotates by theta, the other finger also rotates by theta. So you can clearly see both these angles are congruent without, wasting 20 seconds or 30 seconds on that geometrical part. Yeah, did you see that, everyone? Okay, very good, very good. So guys, yeah, that 8 tricks line trick is also 8 lines trick is also there. That also you can use. This also you can use. This is an additional trick which I am giving. Guys, I have many tricks. I don't know. I can keep giving you 100 tricks also. Anyways, coming back to the point. So to find that, I can see that if I draw a line like this, and I know this is basically going to be 10 centimeter. In order to find this particular theta, what I need to do? This is hypotenuse, this is opposite. So I think I will need sine theta. Sine theta is opposite side by hypotenuse. So opposite side is basically 10 and this is basically r. So I just need to know what is this radius. That's why I need to solve the problem for radius. And to find the radius, I know the formula is mv by qb. But wait a minute, I don't know the speed. Why? Because it is not given. So it is indirectly given. How? It is accelerated through a voltage difference. So let's use that part first. Let's use that particular part first. It's accelerated through a potential difference. So my dear warriors, the potential energy got converted into kinetic energy. So charge into voltage difference will be half into m into your velocity square. Charge is 1.6 into 10 to the power minus 19. Voltage difference is 500 kilo, which is 10 to the power 3, is equal to half into mass of a proton, roughly 1.6 10 to the power minus 27. It's a standard value which you can take. It's having the same numerical factor 1.6, which makes it easier to calculate most of the times, into velocity square. So let's solve this for velocity square. 1.6 gets cancelled. I will have 10 to the power minus 19. 500 into 2 is 1000. 1000 into 1000 is 10 to the power 6. 10 to the power minus 27 will come over here. Just check this out. Perfect. Everybody with me on this, right? So this is basically 10 to the power minus 19, 10 to the power minus 27 will make it 10 to the power 8, 10 to the power 8, 10 to the power 6 will make it 10 to the power 14. So therefore, velocity will be 10 to the power 7. Just check this out. Everybody, till this point, 10 to the power 7 meters per second. Yeah, 10 to the power 7 meters per second. Let's see how many of you have got it. Very good. If you have got it, awesome. Awesome. Now, what is the next thing? What is the next thing? Come on, my dear warriors. Don't waste your time chatting with each other here and there. concentrate on the class. Concentrate on the class. Next thing is to find the radius. Let's find out the radius also. It's not that difficult. Radius is mv divided by qb. Mass is 1.6, same thing, into 10 to the power minus 27. Velocity is 10 to the power 7. Whole thing divided by charge. Charge is 1.6 10 to the power minus 19 into magnetic field, which is 0.51. I can put it as 0.5 approximately. So I'll find out the approximate radius. That's perfectly fine. So how much will this turn out to be? 1.6 gone. 10 to the power minus 27, 10 to the power 7 will make it 10 to the power minus 20. Minus 20 and minus 19 will make it minus 1. So 0.5 will go on the top. It will become 2 into 10 to the power minus 1 meters. So radius will be 20 centimeters. Perfect. So radius is 20 centimeters. This was also in centimeters. So it is basically half. So theta is basically 30 degrees. Theta is basically 30 degrees. Yes, that is the correct answer. I don't need this slide. Yep. Perfect. We got the answer. Got it, my dear students? This is how you solve these questions. So there were multiple levels. Again, electrostatics converting into kinetic energy, electrical energy getting converted into kinetic energy concept was used. Second concept used is the concept of forces on moving charges. Third concept is obviously the geometrical part, right? The basic maths part, which you should know, right? So these three concepts were used in this particular question. Awesomeness. Do I take normal classes also teaching chapters? Yes, we'll be doing that on YouTube. My dear students, I'll be starting a JEE 2025 batch very soon, by next week or so. So we'll be learning the syllabus completely over here, you know, on YouTube live. But that will only happen and continue if you show support and if you make your juniors aware, your batchmates aware, people who are taking drop aware that, you know, JEE classes in English by Shreyas Sir, by your captain and his team is happening on YouTube on the Vedantu JEE English channel. If it doesn't, then I don't have the incentive, motivation. So you need to do that, okay? Because I'm doing it for you, because nobody else is doing it. And not just that, because I feel that we need to produce ranks from South India, from Northeast, from students staying abroad, from students in multiple cities who want to learn in English, students studying in English medium across the country. There are many students in Delhi, many students in Ahmedabad, Mumbai, Pune who love to learn in English as well. So guys, this is a channel for you. Make sure it is popular. Okay. Already we are reaching close to 250,000 subscribers roundabout. Yeah. So you need to make it your channel. Okay. Next question. This is a previous year question. The ratio of the densities is asked of the charges. The two spheres are touching each other. The field at a distance from the center of the smaller sphere along the line joining the centers is 0. Okay. Two non-conducting solid spheres are there. They are touching each other. At some point, the field is 0. Let me just draw the diagram first. In fact, then it will be better. So let's say this is one sphere. Okay. This is the line joining the two spheres. Okay. This is a line joining the two spheres. And the net electric field at a distance of 2r from the center of the smaller sphere. Okay. Both the spheres having charge densities sigma, rho1, rho2. If you take the line joining them, where do you think the net field will be 0? Is it in region number 1, that means somewhere here, or is it in region number 2, that means somewhere here, or is it in region number 3, which is somewhere over here? What do you think? Where do you think the net field might end up cancelling out each other? Region 1, 2 or 3? Quickly think and tell me. Quickly think and tell me. Come on. Yes, Nihad, Ninad Kulkarni, there will be BitSat sessions as well. Most of you are saying option 2 and the answer is perfectly correct. Very good. Proud of all of you. It will be in region 2 because if you go here or here, both the spheres will repel. It will give an outward electric field. In this region, this sphere will also give outward field. This field will also be outward because of smaller one. So they will not cancel. But here, both the spheres might, repel each other. Like this one will repel this side. This bigger one will repel this side. They might end up cancelling out each other. So somewhere in between the two centers, the field will be 0. In fact, the net field is given to be 0 at a distance of 2r. So that 2r can't be this side. It can't be here. It will be somewhere in between. In fact, it is somewhere over here where the net field is going to be big fat 0. In fact, this distance is given to be, this distance from here till here is given to be 2r. But wait a minute, we already know how much is this distance. This distance itself is r. And this whole distance, the radius, is basically 2r. So from here to here, here to here, here to here, everything I know it separately as well. I know it separately as well. In fact, if you go and talk about what is this distance going to be, this distance going to be, because the radius of the big sphere is 2r and this much is also r, so naturally this is also r. Naturally, this is also going to be r, right? So keep this in mind somewhere here. Yeah. So, all these things are important. This is obviously r, even this is going to be r. Think about it. This is going to be r. This was r. This was also r. This was 2r. Okay, I hope you are able to see the lengths clearly now. Okay, so it's little confusing at the beginning, but once you start to draw it on your own, you will definitely be able to get it. Great. Now, once you are aware of this, shall we go ahead, everyone? Perfect. Let's see how to make the net field 0. Due to the smaller sphere at this point, electric field due to the smaller one, which will be towards this side, will cancel out the electric field due to the bigger sphere, which is towards this side. Both are opposite. Due to the small sphere, at this point, the electric field outside the sphere will be given by K charge 1 divided by r square. R is basically 2r. So that 2r, which 2r am I taking? This one, this distance, this particular 2r whole square. That is electric field due to the small one. Electric field due to the big one, it will be K Q2 divided by, now be careful, this point is inside the big sphere. So the actual formula is KQ small r divided by radius cube. Radius of the big sphere is basically 2r. So 2r whole cube and into small r. Small r is the distance from the center to that point. So that is basically capital R. Do you remember this formula? KQ by r cube into x or small r. That is the formula inside a uniformly charged sphere. Instead, yeah, got it? Everyone with me on this? With me on this? Very good, very good, very good. Awesomeness. Now that you have understood it till here, KK will get cancelled. KK will get cancelled. Let's also expand these terms. Q1 divided by 4r square is equal to Q2 r divided by 8r cube. R and r cube will get cancelled as r square. R square and r square will also get cancelled. 4 and 8 will also get cancelled, become 2. So therefore, Q1 by Q2 is basically 1 by 2. This is what I have got till now, but that is not over yet because we have to find the ratio of the density. So for that, remember one simple thing. Charge is density into volume. This is volume density, volume charge density. So Q1 will be density into the volume of this sphere, which is 4 by 3 pi r cube. Similarly, Q2 is the charge on this big sphere. So it is density into 4 by 3 pi, and the radius is basically 2r whole cube. Is that clear, my dear warriors? Is that clear, my dear warriors? Very good. Now this is equal to 1 by 2. This is equal to 1 by 2. 4 by 3 pi, 4 by 3 pi gone. R cube also gone. So rho 1, rho 2 as it is. You have nothing over here left. So 1. 2 cube is basically 8, and this is nothing but 1 by 2. So last thing which will be remaining, 8 and 2 gets cancelled, it will become 4. 4 goes on the top. So rho 1 by rho 2 will be 4:1. So where is 4:1? Option number D. Yes, that is the correct option. So there were multiple concepts involved. Like over here, charge is density into volume, first thing. Second thing is basically the formula of electric field inside and outside a solid sphere. All these things are important. Okay, great, great, cool. Let's go to the next question. In fact, I'll do one thing, guys. I have got an urgent call that I have to go down into the parking. There is some issue, so let me just go down and come up. Okay, I'm so sorry. I'll just give you this question. I'll tell you, take a screenshot of this question. I'm just coming back. Okay, this is a passage question. There are multiple questions on it. I think there is first question of resistivity. Second question is of current density. Third question, I think of drift speed. Yes, drift speed is also asked. And one more thing is also asked, maybe potential difference which is applied. So I think 4 questions are there, I think. Yeah, 4 questions are there, correct. So these are the 4 questions in this particular passage. This data is the same, only these questions are going to change. Just keep solving. I'm going to come because this is slightly calculative. So keep doing it. I'll just come. Give me like 5 minutes. I'm just going to be back. I'm going to be back in 5 minutes. Okay. Okay, I hope you were able to solve these questions meanwhile. So I hope I am audible and visible. My dear students, for the first part, resistivity of the copper under the given conditions, it is clearly mentioned that the current temperature is 60 degrees. At 20 degrees, right, the resistivity of the copper is this much, and the coefficient of thermal resistance is basically 3.9 10 to the power minus 3. So using the formula, which is a resistivity, is original resistivity 1 plus alpha delta T. Resistivity will be given by, original one is 1.78 10 to the power minus 8 into 1 plus alpha, which is 3.9 10 to the power minus 3 into temperature difference 60 to 20. 60 to 20, it is a temperature difference of 40. That's it. You solve it and you shall get the answer as option number B. Option number B. You solve this, you will get it as option number B. How many of you got it as option B? Very good, Luxury Hitler. Yup. Awesomeness. Very nice. Very nice. Moving on to the next part. Of the question. Okay. So these are passage type questions where the theme will be same. Only the question will keep changing. The theme, the scenario will be the same. Different aspects of the scenario might be asked. Current density. How do I find current density? Well, for that, okay, I think I will use this information. Electric field is given. Resistivity we found out to be 1.96 10 to the power minus 8. Resistivity was 1.96 10 to the power minus 8. Now there is a formula, E is equal to rho J. Electric field is 1.5. Rho is basically 1.96 10 to the power minus 8 into J. From this you will get the value of J as 7.65. As 7.65 10 to the power 7. Yep, ampere per meter square. So if you did not solve the previous problem correctly, you cannot get this problem also. So it is a dependent question. So imagine if there are 4 questions in this particular passage and they are dependent questions, assuming each question carries 4 marks, 16 marks if you just understand the scenario and you can solve it. If you don't, then the entire 16 marks is lost. Understood my point? Right? Very good. Awesomeness. All right. Very good. Let's move on to the next question. And the next part of the question is basically drift speed of the electrons. Okay. Potential difference is there. Drift speed has to be asked. Okay, so is there some logic to it? Yep. Current is equal to NVDR. This is the formula. Current by A is current density. So NVDE. So drift speed is nothing but current density by N into E. Yes, this is the formula, my dear warriors. But what is this small n? It is the number of charge carriers per unit volume. In fact, that small n has a separate formula. That small n itself has a separate formula when it is not given directly. It is density into Avogadro's number divided by molecular mass. So that is a direct formula which you can use without wasting time. You can directly substitute it. So m is there below, so it will go on the top. So it will become mj divided by rho na into E. So molecular mass that is given for copper, which is 63.5, but it is in grams per mole, so converted into kg per mole. Current density we found out from the previous problem, 7.65 10 to the power 7. 7.65 10 to the power 7, right? 10 to the power 7. That was the current density which we found previously. So I'm just substituting it over here. This is this is density. My bad. This is density, not resistivity. So density is 8.9. You can see that density is 8.9, but that is grams per cc convert it into kg per meter cube by multiplying by 10 to the power 3. By multiplying by 10 to the power 3. Avogadro number 6 into 10 to the power 23 multiplied by E, which is the electron charge, which is 1.6 10 to the power minus 19. So such calculative questions can also come. After solving, you get the answer as option number D. So you get the answer as option number D. So such questions can come which consume a lot of time, but it will also give you a lot of marks. It will also give you a lot of marks. Moving on to the last part, the potential difference that needs to be applied to produce the same field. Okay. Now, I think electric field is given. The distance is also given. The question is potential difference. Guys, we know this. Delta V by delta R is the electric field. So the potential difference by the length, which is 4, will be electric field, which is 1.5. So the potential difference will be 4 multiplied by 1.5, which is 6 volts. Let's find out. Yep, this was the easiest one of all the 4 questions. This was the easiest one. Correct? Everybody with me? Very nice. Very nice. Very good. Keep it up. Let's move to the next question. I think there was one more question which we had to do, which we skipped because I had to go out. So let's do this question as well. A charge is surrounded by a closed surface of an inverted cone below, and you can also see a hemisphere of the radius r. So if the flux through the conical surface is nq by 6 epsilon naught, what is the value of n? I feel this is very straightforward question, because you can see that charge will generate flux equally on all the sides. It will generate equally on all the sides, something like this. And it is also seen that how much ever flux goes on the top will also go below, So just if you consider this much part, the flux which will go will be q by epsilon naught into half, because half of the electric field lines are going from the top. Similarly, if you consider this much part, exactly the remaining half will go. So that will be q by epsilon naught into half. If you add them, you will get q by epsilon naught, which is the total flux generated by the charge. So the total flux, remember, the total flux generated by the charge is always q by epsilon naught. So what you have been asked is this blue part. So guys, if it is q by 2 epsilon naught, if I make it 6 epsilon naught, I'll have to make this as 3. Only then it works. So n is basically 3. That should be the answer. Yes, it is option 3. It is option 3. How many of you got it? Very good, Luxury Hitler. Awesomeness. Very good. Very good. Proud of all of you. Moving ahead to the next set of questions coming up on your screen. What do we have? Oops. Okay. Yeah, we have a matrix type of question. There are different shaped bodies and their corresponding electric fields are given on the right hand side in column 2. Match the following. One might even go with multiple options. That is possible. Some options might not be selected at all. That is also possible in JEE Advanced. So 1 is too many, or some of them might not be chosen. These things, possibilities are always there. Keep it in mind. Okay, let's try this out. Spherical charge conductor. Let's create a duplicate for this. Spherical charge conductor. What do you think will be the right options for this? Spherical charged conductor. Think about it. When you have a spherically charged conductor, the electric field for this, you will see, oops, it will go, the electric field versus distance will be something like this. It will be 0. Suddenly it will pick up and it will be like this. That's how it would be for a spherically charged conductor. So at the center, the electric field is 0. Yes, definitely. Electric field is uniform. No. Electric field is discontinuous at the surface. Yep, this is also correct. And at the surface, electric field is continuous. No, it is not a continuous. There is a discontinuity at the surface. So that is the correct option for option A. A goes with P and R. A goes with basically P and R. Perfect. Very good. So 2 options are being marked correct. Next, Let's see what will be the correct one. If you take infinite large sheet, so infinite large sheet, the electric field will be both ways and it will be constant. E will be sigma by 2 epsilon naught, which is a constant. So let's see which options will match with this infinitely large sheet. Come on, my dear warriors. There is only one option which I can see which will match. Nothing like surface or discontinuous or center. It's only this option. Only the option Q. Electric field is constant and it is uniform. Everybody with me? Perfect. Let's go to the next one. Uniformly charged ring. Uniformly charged ring. So if I have a ring like this, which is uniformly charged, then what happens is at the center, the electric field will be 0. But at this point, there is electric field, there is electric field. Here also there is electric field, there is electric field. This electric field is obviously not a constant. This electric field is obviously not a constant. So for option C, at the center the electric field is 0. Perfect. Electric field is uniform. Wrong. Electric field is discontinuous at the surface. There is no surface only. So R and S options will not even come because there is no surface as such for a ring. So only option P will match for option C. That is for the ring. Let's go now for the D option. Sphere with uniform volume charge distribution. So when you have a sphere with uniformly distributed charge, then how does the electric field graph look like? It looks something like this, proportional to R, and then it is inversely proportional to R square. So at the center the electric field is 0. Perfect. You can see that at the center it starts with a 0 electric field. Then electric field is uniform. No. Electric field is discontinuous. No. It is continuous, right? So it should be option S as well. It is continuous at the surface. It is continuous at the surface. So it will go with P and S options both. So we have marked everything properly now. Yep. A is going with R and P. B is going with Q. C is going with P. D is going with P and S. Perfect. We have marked all the options. Everyone? Cool? Perfecto? So we have marked everything. Go situation by situation. They are testing you. They are testing all your formula-based knowledge as well over here. Wow, we have got a multiple correct option kind of a question. There is an inductor, resistor, battery, switch. The switch is closed and there is induced EMF and the current. Then which of the graphs are correct? More than one option might be correct. More than one option might be correct. Come on, let's see how to solve this question. Think carefully. It's an inductor based question. Inductor which is charged via battery and a resistor. If you remember correctly, this is nothing but a circuit of growth of current in LR circuits, and the current will grow something like this. I is equal to E by R 1 minus E to the power minus RT by L. And this current, how does it grow, guys? Exponentially, and then it saturates, everyone. If you remember the graphs properly. So there is only one graph which will match. This is decay, this is growth. So exactly option number D. Option B is eliminated because this is the graph of decay of current. This is the graph of growth of current. This is the graph of growth of current. Next important thing is the EMF. EMF is nothing but L times di by dt. When you take the derivative of this, 1 is a constant, so derivative will be 0, right? Derivative will be 0. Slowly you will see it will be something like this. It will be L into E by R, L into derivative of this E by R, then this will be E to the power minus RT by L, derivative of this will be R by L again, right? So LL cancels, RR cancels, so EMF will be E into E to the power, minus RT divided by L. So this you can see is a decay graph because E to the power negative power, it's a decay curve. So option C will be correct, option A will be eliminated. And it kind of makes sense because after some time, after a long time, this inductor will behave like a wire. When it behaves like a wire, wire does not have any voltage difference. So that is why when t tends to infinity, the EMF across the inductor tends to 0 because it just behaves like a simple wire after a long time. So definitely option number C and D should be correct. Let's find out. Yep, it is correct. Option number C and D are correct. Wow, we have got it nice. Perfecto, perfecto. Let's move to the next question. Again, this is a question on electromagnetism. This is specifically from the chapter of AC, alternating current. You can see L is there, C is there, R is there. Resonance situation is given. Voltage is constant by the AC source. The current is how much, resonant frequency is how much, phase difference between the voltages is asked, and the current is it this or this. Either A or D will be correct most likely. So first of all, it is resonating. Once it resonates, my dear warriors, what will happen? The impedance will just become the resistance. So current, which was the voltage by the impedance, will just become voltage by the resistance. So naturally option A is correct. Option number D is wrong. Option number D is wrong. Everybody got it till this point? Okay, impedance will be equal to the resistance. Next important point, at resonance what happens is the voltage across the inductor, voltage across the capacitor will be like this. The voltage across the resistor will be here, which will be the total voltage. These two people will cancel out each other. Don't you see the phase difference between them is 180 degrees? So the voltage between the capacitor and the inductor is 180 degrees in phase. So option C is also correct. Option number C is also correct. Last one, frequency. Omega is 1 by root of LC. Omega is 2 pi F. L, inductance is 1 by pi. Capacitance is 1 by pi, but 10 to the power minus 6. So this will become 2 pi F is equal to pi will pi square's root will be pi will go on the top, and here this will be 10 to the power minus 3. Okay, so pi also goes, so 2F will be pi into 10 to the power 3, minus 3 will go on the top, become 10, sorry, pi has gone, pi went, 10 to the power minus 3 on the top will become 10 to the power 3. So F will become 1000 divided by 2. So F will become 500 Hertz. So which is also correct. So A, B, C options are correct. Yes, D option is wrong. Cool, everyone? Awesomeness. Let's move to the next question then. Let's move to the next question coming up on your screen. Again, multiple correct option. Two non-conducting spheres, same mass and charge, are suspended in air from a common point. Equilibrium angle is alpha. Now they are immersed in a liquid. Dielectric constant. The angle between the string remains the same. Then, okay, I think I will need a separate slide over here. The question is mass density, tension, electric force, so many things. So many things are asked. Okay, let's draw the diagram first. That will be better. I'm just showing the two situations, before and after immersing inside the liquid. The angle is the same. The angle remains the same in both the situations. Whatever was there before is the same. Remember, it is clearly mentioned in the question. The angle between the strings remains the same even after the immersion. The main difference which will happen is the buoyant force will be there. Buoyant force will be there, which will be V rho G. V rho G, buoyant force. Buoyant force will be there. That is one major difference. Before there was electrical repulsion between the two. There was electrical repulsion between the two like this. That is the reason phi they went away from each other in the first place. QE will be the electric, sorry, Q into E will be the electric force acting between them, correct? Q is the charge, E is the electric field between these two particles, right? Now, once you immerse it inside the liquid, the charge is the same, but the electric field will become 21 times less because of the dielectric constant. So it will be QE divided by 21. QE divided by 21. See, this is the change. So buoyant force has also come and the electric field between them has decreased 21 times because of the dielectric medium. Dielectric medium is given to have a constant of 21. That is the reason for it. Okay. Now, let us write equations for this and this separately and see what do we get. Here, if you notice clearly, what will happen is, if I draw this vertical line here also, even this line here also, you will see this is also theta. This is theta. Even this over here is theta. So what I can do is, tension's sine component is balanced by, tension has two components. This is the sine, this is the cos. Sine is balanced by QE. So T sine theta is QE. Whereas the tension's cos component, which is upwards, is being balanced by mg. Dividing both of them, sine by cos is tan theta. So it will be nothing but QE divided by mg. That is what I will get here. Same logic let's apply over here. Tension's cos component, sine component, my bad. Tension's sine component, two components are there, this is sine, is being balanced by QE divided by 21, and the tension's cos component, that is being balanced by mg minus the buoyant force, which is V rho G. Right? The gravity will no longer remain mg because the buoyant force will reduce the net pull downwards because of the upthrust. So mg minus the upthrust force will be balanced by the tension. This much part is clear? This much part is clear? Okay. Now let's divide both of them again. Again I will get basically tan theta is equal to QE divided by 21 times mg minus V rho G. In fact, before doing this, let's do one small change. Let me modify this. Mg minus, what is volume? Volume is mass divided by density of the solid. Sigma is the solid density, rho is the liquid density into rho G. Mg is common. So mg into 1 minus rho by sigma. Now let's divide them and see what do you get. So what I get just from here is tan theta, right? Sin theta by cos theta is tan theta, T1 got cancelled. Why did I use different tension? Because the tensions will change. Why tensions will change? Because the forces are only different. The forces are different, that's why the tensions will be different. That's why I've chosen different variables. I did not use TT over here. That is wrong if you use the same value of the tension. Divide this, you will get QE divided by 21, whole thing into mg 21 times of mg 1 minus rho by sigma. But wait a minute, tan theta is the same. So instead of tan theta, write QE by mg. Write it as QE divided by mg is equal to QE divided by 21 times mg 1 minus density of the liquid. I think it was also given 800. Okay, we'll do that later on. Rho by sigma. QE, mg gets cancelled. Perfecto. So bring these people on the top. So 1 minus rho by sigma is equal to 1 by 21. So rho by sigma is 1 minus 1 by 21. Going to the next slide. rho by sigma is 1 minus 1 by 21. So it will be nothing but 21 minus 1, which is 20 by 21. Rho is the density of the liquid, which is 800. This is sigma. 0, 0 cancels, right? 2 goes with 80, 40 times. So sigma will be 40 into 21. 21 4s are 84. So 840. So 840 should be the answer. Yes, the mass density of the spheres is 840. The electric force between the spheres remains unchanged. Electric force between the spheres reduces. That is wrong. Tension in the strings remains unchanged. Obviously, this is wrong. It changes. It basically changes. Now I'll tell you, the main confusion happens between the first two options. Lot of you might be thinking, sir, how did you mark A? Actually, the answer should be B, because the electric force reduces. Let's have a look at it. Let's have a look at it. Here, the older force was QE. The new force is QE by 21. Naturally, I know your thought process will be, sir, the force has reduced. That is why, sir, I marked the answer as option number B. If you mark the answer as B, even if these answers are correct, if partial marking is not there, your entire question will go wrong. You will get negative marks. You will get -1 marks in spite of doing the entire question correctly. The problem is, understand, whenever you put, let me explain this over here, a medium between two charges. Let's say the electric force between them was F. Now you put some medium between them, put some medium, dielectric medium between these charges, somewhere over here like this. Realize one thing, the force between the two charges never actually changes. It's the dielectric medium which gets polarized and applies a new force like this, applies a new induced force like this, because of which you feel that the net force which is the older force minus the force due to the induced charges in the dielectric medium, that net force is K times less. So this is basically older force by K. So that is the net force between the two charges, which is the force by the actual two charges minus the induced charges in the dielectric medium. So realize this, the actual force between the two charges has never ever changed. The net force has changed. Actual charges still repel with the same force. There is a new force, induced force, that creates a new apparent or net force. Is that very, very clear? How many of you did not know this? Yeah. How many of you did not know this? Come on, quickly think and tell me. If you knew this from before, proud of you. If you did not know this, it's a game changer in the understanding of how dielectric medium and the forces in a dielectric medium work. Cool? Shall we go ahead to the next question on your screen now? This is a JEE Advanced 2017 question, beautiful question with two inductors in parallel and a resistor. Question is, if there is no mutual inductance, ignore it. Switch is open, you close it, the current begins to flow. Which of the following options are correct? Do I have a separate slide? No. Okay, I'll just keep it here. All right. After a long time, the ratio of the currents at t is equal to 0, the current through the resistance is V by R. Okay. First of all, an inductor, just when you turn on the switch, at t is equal to 0, when it is just on, the inductor basically behaves like an open circuit. It behaves like an open circuit. Because it behaves like an open circuit, imagine this to be open, that's it. No current only will go. In fact, the current in the circuit, even if you have closed this, there is no path to flow, the current will be 0. So this option says the current is V by R, which is wrong, which is definitely a wrong option. Hence option D has to be marked as incorrect. Got it? Everyone with me? Okay. Now the next point. The ratio of the current after a long time. Well, for this part, I think option C, I can solve it little bit easily. I'll tell you why. these two inductors are actually in parallel. And in parallel, what happens? The voltage is the same. The voltage is basically the same. And what is the voltage across the inductor? It is L di by dt. It is L di by dt. So L di by dt for both the inductors is same. Dt will cancel. So L1 di1 will be L2 di2. Integrate both sides. Integrate both sides. So L1 I1 will be L2 I2. Therefore, I1 by I2 will be L2 by L1. I1 by I2 will be L2 by L1. So the ratio of the currents through L1 and L2 is fixed. Perfectly correct. It is correct. So option C is correct. Option D is wrong. Till this point, everything is clear. Till this point, everything is clear. Perfect. Now let's go to the option A and B part. Option A and B part. See, you can treat both these inductors as one single inductor, and there will be some current flowing in the circuit, right? And after a long time, what happens after a long time? After a long time, what happens to the inductor? The inductor behaves just like a wire. So if it behaves just like a wire, forget this part. There is only one voltage, one switch, one resistance, and just wires. So the current in the circuit will simply be V by R. Current in the circuit will be V by R. Now this current, once it comes here, it has to get distributed as I1 and I2. But we know what is I1 and I2. We know I1 and I2 ratio. So guys, let's use that. I1 by I2 is nothing but L2 by L1. So using componendo property, I1 plus I2 by I2 will be L2 plus L1 by L1. So I1 plus I2 using Kirchhoff's current law, at this particular junction, it should be I. So therefore, I divided by I2 will be L2 plus L1 divided by L1. So therefore, I2 will be I times of L1 divided by L1 plus L2. But wait a minute, what is I? I is V by R. I is V by R. So the current through the inductor 2 will be this. Just check this out. I, which is V by R, L1 divided by L1 plus L2. Perfectly correct. Nothing wrong. Nothing wrong. You can similarly, I think, prove current through L1 will be V by R. Instead of L1, it will be L2 divided by L1 plus L2. So even this option will be correct. Even this option will be correct. So guys, option A, B and C are correct. Option D is wrong. Let's find out. Yes, that is the correct answer. That is the correct answer. Got it, my dear warriors? Did you love this question? Very nice concepts are involved over here. Really, really amazing concepts. Moving to the next question on your screen. In the circuit shown, there are two parallel plate capacitors, each of capacitance C. Voltages are 2V0, V0. Switches S1, S2, S3. Quite a complex circuit, but let's find out whether the solution is also complex. First, you press S1. Let the capacitor charge and then open it up. Then you press S2, leave it to settle down and then open it up. Lastly, you are closing S3 and then opening it up. Question is, find the charges on the plates. Let's do it step by step. I will make a duplicate of this. Okay, first all of them are open. Let's see what will happen once I start closing one of them, each one of them. Okay, so the moment you close S1, okay, the moment you close S1, so where is it? The switch S1 is pressed to charge the capacitor C1, and then you release it. So this capacitor will get charged. This will become positively charged. This will become negatively charged. This will not have any charges. The charges on the capacitor will be 2CV0. So 2CV0 will be the charge on capacitor C1. Is that right, everybody? Perfect. Now I will open it up. Even when I open it up, nothing doing, no problem at all. Okay, even if I open it up, the charges will still remain on the capacitor C1 as it is. This one is still uncharged. This is still uncharged because it has not yet been connected into the circuit. Now let's close S2. Now let's close S2 and see what exactly might happen. So let's close S2. Let's close S2 and see what exactly might happen. Okay, switch S2 is then closed to charge the capacitor, and it is released also after some time. Now, whatever charge was here, 2 CV0, because the capacitances are same, that will get distributed equally on both the capacitors. The total charge has to remain conserved, right? The total charge has to remain conserved. So this will be plus, this will be minus, this will be plus, this will be minus. Earlier it was 2 CV, remember that. 2 charges, 2 CV charge, minus 2 CV charge. Now, one of the charge goes here equally, it gets distributed something like this. So this will have CV0, this will have CV0 charge, and this will also have CV0 charge. Next step, you're opening the switch up. You're opening this switch up. Okay, fair enough. The charges can't go anywhere. This is settled down over here. Last step, S3 is closed. S3 is closed. What will happen? Okay, let's figure that out also. S3 is closed. When I close S3, S3 is closed after some time. What will happen? Think about it. This battery will only charge this capacitor. This is negative terminal, so this will become minus, this will become plus, and the charge on this will be nothing but C times of V0. C times of V0, correct? This C1 is disconnected from the entire circuit, so whatever charge was there before will remain on it. So plus minus over here. So this will be plus, this will be minus, this will be CV0 charge. So this is the final condition of the circuit. This is the final condition of the circuit. I will show it to you right from beginning how it has changed so that you get an idea. This was open, you close it, this got charged to 2 CV0. You open this, this charge remains as it is, this has no charge at all. You close S2, one of the charge will go over here and it will get equally distributed. You open it, nothing will happen, the charges have no place to go. Now you close S3, this capacitor will get charged, this will be minus, this will be plus. This has nothing to do, so it will remain as it is. So this is the final state. So guys, the correct answer should be B and D. Just check it out. Why? The charge on the upper plate of C1 is 2 CV0, right? That is wrong. It is plus CV0. The charge on the upper plate of C1 is just CV0, correct? The charge on the upper plate of C2 is 0. That's wrong. It is in fact negative. So it is minus CV0. That is the correct answer. So B and D. So B and D. Got it? Very, very nice question. Okay. So the next few questions are homework. So this is the first homework question. You can take a screenshot. You can solve it. Put the answers in the comment section. Okay. You can pause the video. You can take a screenshot. This is your homework question. Answer is there on the next slide. PDF will be shared with you. PDF will be shared with you later on the Telegram group. The Telegram group link is there in the description box below. This is your second question, homework question. Just try to solve it. Take a screenshot of this. Okay, I think it's based on alternating current, right? And probably, yes, one more homework question is there for all of you. This one is also simple. Okay, this was asked in JEE Advanced 2021. Try it out because these are the common type of questions which are asked in JEE Advanced. So you should be aware of these patterns, these modules or these models of question. Okay, so this is your third homework question, integer type, integer numerical type. Yeah, all right. So I hope you all enjoyed this session. I hope you all learned a lot from this session. Tomorrow, hopefully, we'll be able to take the class for waves, oscillations, sound, light waves, electromagnetic waves, all these things combined, all the wave oscillating things combined, 11th and 12th standard syllabus questions for JEE Advanced. Okay, see you guys tomorrow. Share this session with your friends. Do not forget to like and let me know in the comments how much you loved this session and what else you want from my side for JEE Advanced. Okay, bye bye. Captain Shreyas signing off. Take care. Hasta la vista.